So hi everyone. In this video, we are going to solve the problem Leetcode 99 recover binary search tree. So the problem states you are given the root of a binary search tree where the values of exactly two nodes of the tree were swapped by mistake. Recover the tree without changing its structure. So what the problem states is we are given a binary search tree and exactly two nodes were swapped. So if we look at this example, we can see that node 3 and node 1 are swapped. So this makes an invalid binary search tree. So we need to find those two nodes and swap it back. So the answer would look something like this. So 3 comes here and 1 comes here. So this becomes our valid binary search tree. So how do we solve this problem? And we all know how to do an in-order traversal, right? So if you don't know how to do an in-order traversal, just learn how an in-order traversal work. So we know that in binary search tree, if we do an in-order traversal, we will always get an sorted array, right? So we will use this property to our advantage. So for example, let's take a binary search tree. So 7. So let's say this has 5, this has 10, here 1, here 2, or 2, let's say 6, here let's say 8, and 11. So let's perform in order traversal here. So first is left becomes 1, then 5, then 6, then 7, then 8, then 10, then 11. So as we can see, the array is a sorted list, right? So if we perform an in-order traversal in a binary search tree, this will always guarantee us a sorted list. So we will be using this property to our advantage. So let's say we replace these two with here comes 8 and here comes 6, right? So now let's do an in-order traversal. First comes 1, then 5, 8, 7, 6, 10, and 11. So as you can see, 8, 8, and 6 were swapped, right? So we need to swap this. How will we find? We keep on checking at each traversal, we keep on checking whether that number is greater than the previous number or whether it is lesser than the previous number. Since we are moving in an ascending order, we check whether the previous number is smaller or not. If it is smaller, then it is a valid uh, the node is in the valid position. If it is not, that means it has been swapped and we need to consider that node. If we check 1, let's start with 1. 1 is here. The previous node will be null. So we do not consider 1. Let's start from 5. The previous node is 5, which is smaller than 5. So it is a valid node. Let's go to 8. The previous node is 5, which is smaller than 5. So still it is valid. We move. Now we check. The previous node is 8, but the current value is 7. So that means the previous node should have been swapped, right? So we take this as our first node, which should be swapped. Okay, now let's move again. We are here. The previous node is 7, the current node is 6, but 7 is greater than 6, right? So we come and mark this as and the next node which should be swapped. And at the end, we will be having these nodes to be swapped. Since the problem says there is exactly two numbers which are swapped, we can always confirm that these two values will be our nodes to be swapped. So I'll be sharing you the code and explain it for better understanding. So yeah, this is the code. So first we will be having three variables, which will say previous node, first swap and second swap. These two will be required to find our answer. So the previous node will hold the previous number as we saw here. So let's take this for understanding 1, 5, 8, 7, 6, 10, and 11. So 8 and 6 are the numbers which are swapped. Okay. First, we will do an in-order traversal. We come here. This will make sure our in-order traversal will work. Before looking at this problem, just as I said before, just learn what is in-order traversal and how to solve it. Only then you'll get a better understanding of how to solve this problem. So as I explained before, I'm going to check here whether the previous node value is greater than the node value. If it is greater, I'm going to check whether the first swap node is empty or not. If it is empty or null, that means the first node has not been found. I'm going to fill it with the previous value. That's what we found here. At this position, I'll be coming inside this block because 7 is not greater than 8, right? Only then I'm going to come into this position and I'm going to check this. The first case, only to find the first node, we need the previous value. So we are going to set here as 8. And we are assuming that this element 7 might be our second value which should be swapped. So we are putting it in the second swap node. We keep on moving, and once we find a node which is smaller than the previous value, we come in again. But in this case, our first node value will already be filled, right? So we update the value with the current node, which will be 6. So this will be the code to solve this problem. And guys, please do dry run this. At the beginning, it would be a bit difficult, but once you dry run this, this would be a very easy problem. So that's it for the video. If you guys understood, please give this video a thumbs up and subscribe to this YouTube channel. So see you soon in the next video. Bye bye.